All right, so guys, difference quotient. Here we go with the first example. All right, so guys, there's a little bit of overlap on the video. I got about halfway through this one, second period, but wanted to get through the entire thing. So guys, this first example, I just realized something. We didn't pass these out. All right, so guys, we're going to add to your notes a little bit.
Oh, no.
Mainly because I thought that you could use more than one example.
I knew there was a catch. Oh my god. Also, we haven't taken any numbers. I don't know what we're doing still.
All right, so guys, the examples that we're going to go through. This one might show up twice. I can't recall.
Wow. Murder.
All right, so guys, this first example, example number 5. The second example that we're going to get into, the first like real all-in type of problem, you'll notice is number 48 off of your homework assignment tonight. Okay, so again, we are quite literally doing a homework problem. We're going to try to do that together. So again, time permitting, of course, but we should be fine. But guys, number 5, this particular problem, this is going to be the easiest one that we do because in a way the training wheels are still on. Okay, that was the way that I was saying it second period. You'll notice that the difference quotient is f of x plus h minus f of x. Here we have a 3 in place. So we know in this particular problem, okay, x must equal 3. Usually that's not the case. Usually we don't know what x is equivalent to. So like I said, we're trying to ease into these types of problems, just so you're aware. All right? So the whole key to success, like I said earlier on these problems, is to stay organized. If you can stay organized, these problems are going to be simple. If we struggle to stay organized, well, yeah, it's going to be tough. There's really no way around that. It's going to be much harder if you're I'm kind of work all over the place kind of person. Okay, so we need to go off to the side and we need to figure out that top left, f of 3 plus h. We need to go off to the side and figure out the top right, f of 3. When we're ready, we're going to sub those back into this difference quotient. Whatever I got for f of 3 plus h, whatever I got for f of 3, we plug those back in. And what you're going to notice is that every problem works the same. We're going to have some stuff that subtracts out. Then we probably have to factor. And we know that we haven't been able to use direct substitution because I have an h in the denominator, which tells me we want to divide the h out. Right? Every time, that's going to be our plan. So let's see what this is going to look like here. Off to the side. I'm even going to label it side. All right, off to the side. We want to figure out the top left. So the top left for us is f of 3 plus h. All right, now let's not overcomplicate this. We're given the function f of x is equal to x squared minus 1. So if that's my function, what do you want to use? Again, this is totally unrelated, but honest, what number should we use? 2. So if we were to find f of 2, do we know how this operates? X squared minus 1, what do I put in place for x? 2. We're going to put 2 in place for x. 2 squared is 4, 4 minus 1. F of 2 is going to be 3. We're good with that, right? We've done this a million times, it seems. What if it gets a little bit more complicated, and we're not finding f of 2, but instead we're finding f of 3 plus h? Well, what am I going to put in place for x? 3 plus h. Now, it might look weird initially, but it's no different, is it? We literally put 3 plus h in place for x. That's it. Now we have to evaluate it. Yeah, that's what we're going to do over here. F of 3 plus h, we said that's going to be equal to 3 plus h squared minus 1. All right, so as we clean this up, I suppose I said the biggest issues or the biggest errors I neglected to say. Are we all okay with the fact that this is not 3 squared plus h squared? You can't just distribute the exponents. It doesn't work like that. We actually have to FOIL this out. 3 plus h times 3 plus h minus 1. So as we multiply, like I said, we're just distributing. We're using the FOIL method. First here, 3 times 3 is 9. Outside would be 3h. Inside is 3h together. That's 6h. My last term, h times h is h squared. Can't forget about the minus 1. So what are you going to tell me, please? F of 3 plus h. Does anything simplify or cancel out or subtract out or any like terms, anything like that? Yeah, we've got the 9 and the negative 1. So can we rewrite this as h squared plus 6h, and I know that 9 minus 1 is positive 8. Any other like terms here? Nope. So do we agree that f of 3 plus h is this value, or this trinomial, I should say, h squared plus 6h plus 8, and when the time comes, that's what we're going to plug in place to the top left. One down, one to go, right? So we're good with the top left. Everybody's in agreement that we feel really confident with what's happening on the top left, which leaves us now with the top right. So what is the top right supposed to be? F of 3. Okay, so now this one's a little bit more along the same lines as what Onyx was saying when the question was, what should we put in place? And Onyx told us f of 2. Okay, could we find f of 3, I guess is my question. F of 3, the function is still x squared minus 1. What am I going to put in place for x, though? 3. Again, a little bit more comfortable this way. This is the same way we've been doing this stuff for years. Right, so 3 squared is 9, minus 1. We all agree now that f of 3 is merely 8. So when the time comes, do we know what we're going to plug in place to the top right? Yeah, we're going to put 8 in place for f of 3. Right here. All right, so I mentioned when the time comes a couple of times. I think we're ready. So I'm going to try to block this off a little bit. Let's go ahead and rewrite that difference quotient. We're supposed to find the limit as h approaches 0. We cannot use direct substitution because, again, we have 0 in the denominator if we do. So we know that we've got the top left minus the top right all over h. So what did we say the top left was going to be? Good. H squared plus 6h plus 8 minus the top right, f of 3, we said was 8. All right. Pausing here just for a moment. Everybody's good with what we just did. Now we plugged all that stuff in. Can we use direct substitution now? Nope. Still would have a 0 in the denominator. So no, we are not ready for it. But we do have a bunch of cancellations taking place. What's going to cancel the numerator? 8, negative 8. They're going to subtract out. So now my numerator, let me write this up. I'm still finding the limit as h approaches 0. Don't want to lose that. But my numerator is going to be h squared plus 6h over the denominator h. Oh, 8 subtracted out. Now can I use direct substitution? Still no. But what can I factor out of the numerator? Factor an h out of the numerator. Good. So the limit as h approaches 0 of, when I factor the h out of the numerator, that's going to leave me with h plus 6 all over h. Now, what is the key thing that happens here? How the h's divide out. Remember, we were trying to use the dividing out technique all along, and it just happened. We just divided the h out of the denominator, which now puts us at the limit, excuse me, as h approaches 0 of h plus 6. Now can we apply the direct substitution? Is there any reason why I couldn't put a 0 in place for h? None whatsoever. So in doing exactly that, directly subbing 0 in place for h, 0 plus 6, you're going to tell me is 6. And we found the limit as h approaches 0. All right, so for that particular problem, like I said, we got a numeric value. We got 6. I'm here to tell you that usually that's not going to be the norm. Remember, we knew what x was. This was an easier problem because we had x provided. What's more realistic, probably, is going to be a problem like this one. So I wanted to pull one directly off of your homework assignment. Let's go ahead and take a look at number 48. But guys, the game plan is identical. Sure, the function changed, and the biggest difference is that we don't know what x is. Okay, x is going to stay generic. It's going to stay x. So our plan is we need to figure out the top left, f of x plus h. We need to figure out the top right, f of x. When I say figure out, that is probably overstating it because aren't we given f of x? So do we already know what we're going to plug in place for the top right? Yeah, we're given that f of x is x squared minus 3x. So yeah, we're in pretty good standing the way it says. But off to the side, we do need to figure out the top left. So the top left for us is to find f of x plus h. So as we are doing that, f of x plus h, I know that this seems weird. But remember what we did on the previous slide. If we wanted to find f of 2, we put a 2 in place for x. If we wanted to find f of 3, we put a 3 in place for x. If we wanted to find f of 3 plus h, we put 3 plus h in place for x. So here now in this problem, if our function is x squared minus 3x, and I'm trying to find f of x plus h, what am I going to put in place for x? X plus h. I know that that seems a little weird this first time that it's happening. You're telling me that I could put x plus h in place of x? Yes, that's what I'm telling you. And I know that it looks weird, but that's what we're doing. Okay? It works out. I promise you. So just like before, we're trying to figure out this target of the top left. I have to square x plus h times x plus h. Can I distribute the negative through, and call that negative 3x minus 3h? Are we good with that? I was going to say, like, a head nod goes a long ways here. All right. So, multiplying the binomials. So, FOIL method. First, we get x squared. Outside xh, inside xh. So, together we have 2xh. And then our last term plus h squared. We still have the minus 3x minus 3h. So, question for you. Does anything combine here? No. So, good news and bad news, I guess. Good news is we found it. Bad news is I would have felt better about only having 2 or 3 terms instead of having 5, but hey, those are the breaks. That's the way that it happens. When the time comes, we now have what we're going to put in place to the top left. Okay? Speaking of breaks, we may have caught one here. In the top right, we're supposed to find f of x. Again, that's overstating here. F of x is just given to us as x squared minus 3x. So do we agree that that's actually what we're going to put in place to the top right? Like here? Okay. So our side work is done. We're ready to go. So, in finding the limit as h approaches 0 for this problem and every other, we cannot use direct substitution because we would be putting a 0 into the denominator. So as the time comes for us to plug in our findings for f of x plus h, remember that we said that we had x squared plus 2xh plus h squared minus 3x minus 3h. Minus, all over h by the way, minus x squared minus 3x. All right. Number one biggest error and mistake that, that students make. I just did it right here. What did I neglect to do? Yeah, again, I saw like 2 or 3 people just do this. I'm assuming you're meaning that you want me to put parentheses, okay? I don't care if you jump directly into this second step that I'm about to do, or if you write it out the way that I did here. Guys, we have to distribute that negative through. When you're subtracting a polynomial, we absolutely must distribute that negative through. So now as we're finding the limit as h approaches 0 of, that's going to be, again, most of this is unfazed, x squared plus 2xh plus h squared minus 3x minus 3h. Just copying all of this down. But when I distribute the negative through, it's now minus x squared plus 3x still over h. And guys, if we screw up the sign, we just simply won't have the cancellations that we need. What's going to cancel in this problem? In the numerator? X squared, x squared, negative 3x, positive 3x. They're gone. So my numerator, I get my limit written up here, limit as h approaches 0. My numerator is now 2xh plus h squared minus 3h all over h. And guys, we could go with whatever order we want. But what's really important, I'm trying to go dividing out technique. What could I divide out of the numerator? H. We could divide h out of the numerator. Good. So in pulling that off, limit as h approaches 0 of, dividing the h out, that's going to leave me with 2x plus h minus 3 all over h. Now what happens?
Yes.
The dividing out technique works, leaving us with the 2x plus h minus 3. Are we allowed at this point to apply the limit as h approaches 0? I don't see any reason why not. So we have 2x plus 0 in place for h minus 3. 2x minus 3 is going to be the limit. Now again, this is the derivative. So do we know exactly what x is? It can be anything we want. If we wanted x to be 3, guess what? We plug a 3 in place for x. If we want x to be 10, we plug a 10 in place for x. If you want x to be negative 4.137, I don't know why, but yeah, you can plug that in. You can plug in whatever you want for x at this point. All right, questions on that one? All right, I have to stop the video here.